All right, guys. So video number 2 for today. Okay, so this one, I'm just going to introduce this topic, but I mean, you've done this in grade 9, so I'm just here to refresh your memory. All right, so there's something, here we see the balloon. I just wanted to remind you what we did before. So in this case, I'm going to show you this. It's electron theory. Normally I go through the history and everything, but I mean here, a brief history of electricity. In the ancient times, people picked up, pieces of amber, rubbed it. And why my amber is that it's petrified tree sap. Okay, it's like it's a stone, right? It's like the color of maple syrup, sort of. Anyway, amber happens to have a high affinity for electrons, and when you rub amber, here actually you can see it on this list. Okay, when you rub amber with wool or fur or anything else, see here's amber right here. If you were to rub it with, for example, rabbit fur, okay, or cat fur or whatever, okay, wool, whatever clothes they wore thousands of years ago, you know what I mean? Like, they wore furs and wools and whatever they had, okay? It becomes negative. So amber has a high affinity for electrons, almost as good as a rubber balloon, okay? And when you rub amber and fur, it tends to become negatively charged, okay? And so what happens is the Greeks noticed this, and then they noticed that the amber had this sort of different quality to it after you rubbed it with fur. Now, if you've rubbed anything like a balloon on your head or something, you'll notice your hair will stick to the balloon. So something different about your hair before and after you rubbed it, right? So, basically the Greeks said it was charmed or charged, okay, is what we say now. And they realized very quickly that there were two kinds of charge, positive and negative, okay? And basically, they arbitrarily called them positive and negative. They thought the positive charge was gaining something and the negative one was losing something, okay? Now it turns out that they got it backwards, okay? What they thought was the positive object actually got positive by losing something, okay? So they were right that something was being transferred. They had no idea what it was, but now we kind of know, right? So, 2,000 years later, we kind of figured this out. And so here are, let's sort of go to the modern theory. And I'm just going to say number 1. Atoms have positive charge. Protons in the nucleus. Oops. And negative charged electrons in, we'll call them orbital shells, even though they don't really orbit. But anyway, that's a discussion for chemistry or for quantum physics later. Anyway, the point is they're not in the nucleus, okay, and they're easily removed. Okay, so number 2, in solids, protons are held by the strong force. It's not called the strong force for no reason. It's called the strong force because it's very difficult to break it, okay? And not easily moved. And I'm just going to write nearly impossible to remove, or to add more for that matter. It's not impossible. I mean, we call it nuclear fusion when you add more protons to the nucleus. We call it nuclear fission, if you like, if we sort of separate off a piece of the nucleus. But the thing is that those unless you're talking about very heavy elements, these things are quite rare, okay? Like especially fusion, that hardly ever happens inside the core of the sun, okay? Like that's where fusion happens. But here at regular temperatures, like lower than 15 million degrees Celsius, it almost never happens, okay? Electrons, on the other hand, are easily moved, okay? And the deal is, number 4, the deal is the movement of electrons okay, can explain all electrical effects, okay? So if there's a lightning strike, or if there's current flowing in a wire, or if there's, you get a shock because you put on a sweater over top of your cotton shirt or whatever, and there's a shock that you feel, or a little static discharge, or clothes stick to you, or the balloon sticks to the wall, whatever the case may be, we can use electron theory to explain it. Okay, and that is what electron theory is all about. Okay, now I'm just going to say note, a couple of notes. Protons and electrons are very different, but they carry the same amount of charge. Okay, so the charge on a proton is equal to the charge on the electron. They're very different mass and very different characteristics. Everything else is different about them, but the amount of charge they have, except like they're equal in size, but of course one's positive and one's negative. This is plus, this is negative, right? Okay, so they're opposite in sign. Whoops. In sign, but equal in magnitude. Okay, so that's item number 1. Item number 2. A positive charge on an object, what does it mean? Well, it means you have a deficit of electrons. In other words, electrons have had to have been removed from those atoms in that object, okay? A negative charge means an excess of electrons. In other words, electrons must have been added to that object. And a neutral charge means equal numbers of electrons and protons. Okay, so there you go. That is, in a nutshell, all the sort of little points I can make about electron theory. Now, I have to apologize for my pen because my pen is kind of broken. I ordered a new tip for my Surface Pen here, so my writing will be worse than it normally is, so that's an adventure for you. Okay, so all right, so now that we have this, your assignment is to use this to explain, say, charging by friction, charging by induction, grounding, and stuff like that. So pretty straightforward. You should have done it all in grade 9, so it's just a review, but let me show you how it works. I'm going to do charging by friction for you. Okay, so I showed you this demo, charging by friction, where the balloon is charged by rubbing it on the sweater, and it gets charged by friction. Okay, and the balloon became negative. Why did it become negative? Well, because it has physical properties, okay, like the atomic structure of that material means it has more attractiveness to the electrons. And so what it does is it will, when you rub them together, will pick up electrons from the wool and they'll transfer them into the rubber. But since the rubber balloon is a poor conductor, the charge just sits there after that. Okay, and that's why we call it static electric charge. Static means it's not moving, right? It's just sitting there. All right, so here, I'm going to do charging by friction. All right, So charging by friction works because different materials have different attractiveness towards electrons. Okay, so here at the top of this list, what you will see is human skin at the top of the list. Your skin has a very low affinity for electrons. Okay, your hair comes somewhere in that category also, rabbit fur and so on. So fur, hair, and so on have typically a weak hold on electrons. However, these items at the bottom, which happen to be like a lot of them artificial compounds like polymers, vinyl, polyester, right, rubber balloons, ebonite, okay, they tend to have strong holds on electrons. And the reason is just because of their molecular structure, okay? So certain things have stronger holds on electrons for whatever reason, even though all of these things, most of them are non-metals, I think, okay, wood and so on. And so, yeah, but even among non-metals, they're not all equal in terms of their affinity for electrons, okay? So some things have stronger pull on electrons than other things. And when you rub them together, the thing with the stronger pull will gain electrons from the guy with the weaker, okay, pull. So I can just explain it like this. When two materials are rubbed, okay, and this is the friction part, and you need to have a little bit of friction. I can't just touch my skin to a rubber balloon and expect it to become charged, or my hair. You got to rub it, right? In other words, like you got to get a little bit of friction in there to get the electrons to make their way across. They won't do it for free. You have to give the little push, and that's where the friction comes in. The material with, the higher affinity means attractiveness, for electrons will draw electrons from the material with the lower affinity. Okay, and so therefore, here, if I want to show it like this. Let's say I have two objects, A, and I'll just make this one, this is fur or something, B here. Okay, so this one has the higher affinity. This one has the lower affinity. Okay, you rub them together. Okay, and what happens is electrons will make their way over to that guy. So he's going to lose, B will lose electrons, right? So B loses electrons. And if it started out as neutral, it'll therefore have a positive charge that's remaining. Just like the sweater in our picture here, when it loses its electrons, has now a positive charge. It didn't gain protons to get a positive charge. I can't do that. It did lose electrons though. Okay. A gains electrons, and this leads to an overall negative charge. Okay. And that's charging by friction. I mean, that's basically it. Okay, now here we see in our example that our balloon has gained electrons. Now it's negative because it's got all those extra electrons in there. There's one more thing I need to mention. I guess I'll throw it into the notes just up here. Another note. The law of electric force. Opposite charges attract and likes repel. This is very much unlike gravity, which does not have a repulsive force. It's all like there's no negative mass, right? Like everything has a positive mass. And so it attracts everything else. But for gravity, there's no opposite charges to begin with. It's just mass. And all mass attracts other mass. So gravity is only attractive, whereas electricity can be attractive or repulsive. Okay, so that's one difference between electricity and magnetism. All right, so that's it for today. I want to show you this. So it's kind of short, but there is another lesson in the outline. Okay, we are already on lesson 2. Okay, so I want to check something off for you though. I did charging by friction, so you don't have to do that one again. Okay, so in the homework, there's no textbook homework for lesson 2. You just do 1, 3, 4, and 5. Okay, and just put that in your notes, please, and upload it to OneNote. You can also take a look at this. It's not very much. There's 9 questions there, but they're pretty easy. Okay, and actually tomorrow, I'm going to give you this, and that'll be it for this week. Okay, so my goal is to sort of over the next couple of weeks get through all of this. Okay, and then we're not doing a final exam, so we should have time to do the sound unit at the end, and that'll be it for the course. All right, guys, so listen, if you have any questions about this, let me know. Remember why we're doing this. We're doing this for one reason, so that you can prepare for grade 12. Like some of you, like I know that your marks might not matter to you anymore, like in the sense that you can get the mark you got before the March break, whatever it is, but don't forget, I just want to remind you, you're doing this now, so you care about school and you want to be prepared for next year. Okay, so I teach grade 12 physics too, and there must have been a lot of you that signed up because I have 2 sections of grade 12. And so however that's going to work next year, we do electricity again in grade 12, and like some of that is for first year university. Okay, so yeah, it's kind of important. It's not difficult either. So please, let's get through doing this together. Those of you who've been following along and doing your work, amazing. I really appreciate that. And I know it's not easy sitting at home, but we'll get through it. Okay, so yeah, that's it for today. And we will talk to you again probably tomorrow, or if not, on Thursday. Okay, guys, have a good day. See you later.